Welcome guys to my first video tutorial. In this video, I will explain Einstein's theory of relativity. This is the theory Einstein is famous for. The book was first published in 1905 and it contains most of Einstein's brilliant ideas. The theory states that time is relative because Einstein observed and experimented on how object speeds vary when measured in different inertial frames of reference. A car driver, for example, appears stationary when viewed relative to the car's inertial frame of reference, but relative to the Earth, the car, with a driver in it, moves at 15 meters per second. The Earth on which the car is located appears to be stationary, but it is moving at 30,000 meters per second relative to the Sun. To better understand the concept, let's imagine two boxes in space made entirely of glass, box A and box B. In each box, a person is observing. For simplicity, let's pretend that the boxes have lengths and widths of 1 meter and are initially 1 meter apart. Now let's make box A stationary and let's move box B to the left. At 0 second mark, the two boxes are stationary. Every 1 second, box B moves 1 meter to the left. The shaded spaces show the previous position taken by the moving box relative to its initial position in space. By dividing the horizontal dimension of the shaded spaces by the elapsed time yields 1 meter per second, it can be inferred that box B has a speed of 1 meter per second in relation to its initial position in space. But what would be the speeds of the boxes relative to each box's inertial frame of reference? Answer is, from the point of view of the person inside box A, box B is moving at 1 meter per second. Likewise, from the perspective of the person inside box B, box A is the one moving at 1 meter per second. To put it differently, each observer inside each box would assume that this box is stationary or at rest, and the other box is moving at a speed of 1 meter per second. The second scenario involves box A moving to the right and box B moving to the left. At 0 second mark, both boxes are stationary and are 1 meter apart. Each second, box A moves 1 meter to the right and box B moving to the left, as indicated by the shaded spaces. Same color means same moment in time. If we divide the shaded spaces length of box A by the elapsed time, we get a speed of 1 meter per second relative to its initial position in space. Similarly, if we divide the shaded spaces length of box B by the elapsed time, gives 1 meter per second relative to its initial position in space. How about the speeds of the boxes relative to each box's inertial frame of reference? The answer is the sum of the two boxes' speeds. That is, from the perspective of the one inside box A, box B is traveling at a speed of 2 meters per second. From the perspective of the person inside box B, box A is moving at a speed of 2 meters per second. In other words, each observer inside each box assumes that the box he is in is stationary and the other box is moving at 2 meters per second. In the third scenario, we let both boxes move to the left. At 0 second mark, both boxes are stationary and are 1 meter apart. Every 1 second, both boxes shift by 1 meter to the left. In 2 seconds, 2 meters, and so on. By dividing the length of the shaded spaces by the elapsed time gives 1 meter per second, which means both boxes move to the left at the rate of 1 meter per second. Can you guess now what is their speed relative to each box's inertial frame of reference? Answer is the difference between the speeds of the two boxes. From the perspective of the person inside box A, box B is traveling at 0 meters per second or stationary. From the perspective of the one inside box B, box A is also traveling at 0 meters per second, or stationary. It means that from both boxes' perspectives, it appears that the other box is not moving. If the speeds of the two boxes are different, for instance, box A has a speed of 1 meter per second and box B has a speed of 2 meters per second. Each second, box A shifts 1 meter to the left and box B shifts 2 meters in the same direction. The difference between the speeds of the boxes is 1 meter per second. We can conclude that from each box's perspective, the other box is traveling at a speed of 1 meter per second. Now, Einstein said that the speed of light is the only thing that is not affected by this phenomenon. He claimed that the speed of light is the fastest moving object in the universe and added that the speed of light is the universal speed limit and nothing exceeds. Regardless of the inertial frame of reference and the motion of the light source, light has always generated the same speed of 300 million meters per second. To provide a better explanation, let's assume that the two boxes in space, box A and box B, are 300 million meters apart. Box A has a clock-based observer who will record the speed of light as it reaches him, while box B has a mounted light. This time, both boxes will remain stationary. Box B will turn on its light every 1 second. As expected, the beam of light from box B reaches box A at exactly 1 second. The observer in box A will record 300 million meters per second. In the second scenario, let's change the distance between the two boxes to 299,999,997 meters and let the light source, which is box B, move to the right at 1 meter per second for 3 seconds, so that at exactly 300 million meters, we turn on the light in the direction of box A. The question is, what would the observer in box A record after 3 seconds? Logic dictates that the observer will record 299,999,997 meters per second because the light travels opposite to its light source, which is box B. This is analogous to a motorboat traveling at a speed of 15 meters per second opposite to the river flow of 5 meters per second. The resulting speed of the motorboat will reduce to 10 meters per second. But no, the observer in box A will record 300 million meters per second. In the third scenario, let's change the distance between the two boxes to 300 million 3 meters and let the light source, which is box B, move to the left at 1 meter per second for 3 seconds, so that at exactly 300 million meters, we turn on the light toward box A. What would the observer in box A record after 3 seconds? Logic dictates that the observer in box A will record 300 million and 3 meters per second. This is the same as a motorboat traveling at a speed of 15 meters per second along with the river flow of 5 meters per second. The resulting speed of the motorboat will increase to 20 meters per second. But that does not apply to light. The observer in box A will record 300 million meters per second. With these results, we can deduce that the speed of light is immutable. The faster an object reaches that speed, says Einstein, the more time dilates. The slower the object moves relative to that speed, the faster the passage of time. Hence, a spaceship moving at 1 meter per second will have a time 300 million seconds faster than each tick of light's time measured in seconds. A spaceship moving at 150 million meters per second will have a time 2 seconds faster than each tick of light's time in seconds. A spaceship moving at 300 million meters per second will have a time equal to each tick of light's time. What if a spaceship's speed were to exceed the speed of light? Then that spaceship's time would decrease beyond light's time. For example, a spaceship traveling 2 times faster, the speed of light at 600 million meters per second, will have a time 0.5 seconds lower than each tick of light's time, measured in seconds. A spaceship traveling at 3 septillion meters per second will have a time of 0.1 times 10 raised to the power of negative 17 seconds more slowly compared to each tick of light's time in seconds. If we continue to increase the spaceship speed indefinitely, the resulting time will eventually approach zero or stop, and the person inside this spaceship will not age and will become immortal. That's all, folks. Please subscribe, share, and like this video to inspire me to create more videos.